All right, so the last 2 days, right, we've talked about scientific notation. Last week, we actually spoke about multiplying and dividing monomials. This lesson is kind of where both of those lessons are kind of merged together. All right, so what we're going to talk about is how to compute scientific notation. We're going to do that by using some of the skills that we've already talked about. All right, so it's kind of like taking those skills, knowing in which order to do them in to be able to get the right answer, and when to use those skills and when not to. Okay, so here is what we're going to do. So hopefully all of us have our books out, right? Our papers, please make sure first and last names on your paper. Book page, all right, assignment number. Some of us don't have it on there, so make sure that's on there. Okay, date, all that good stuff. All right, so let's go ahead and let's take a look at book page 163. All right, this is one of those that I'm going to do. You're just going to watch, and then I'll let you guys write down the answer right afterwards, and you'll be okay. All right, so here it is. All right, number 12 looks just like this. 1.48 times 10 to the negative fifth times 6.5 times 10 to the negative sixth. Okay, so here we go. What we have is we're multiplying two products, basically, or two numbers scientific that are written in scientific notation to simplify them. Okay, so here's what we're going to do on a problem like this. Here's all you do. The bad news is that these will have a little work involved. The good news is that ta-da, you get to use a calculator tonight. Yay! Okay, so but please pay attention at the work you do need to show. Calculators are only used. Let's refocus. Calculators are only used for the large multiplication and division part. Okay, in this case, the decimals. All right, so here we go. All right, so the very first thing I'm going to do is I'm going to multiply my numbers. Remember, this is all I know they're two scientific notations and they represent two different numbers, but ultimately it's just all one long multiplication problem. That allows us, okay, using, you could say, commutative property or associative property of multiplication, to multiply the 6.5 with the 1.48, and I'm going to get 9.62. Now what I'm going to do is I'm going to put multiply by, and now I'm going to multiply my in part, which actually are monomials. So remember, they have the same base, which is 10, and I have a negative 5 and a negative 6. I add those together. So negative 5 and a negative 6 added together is a negative 11, and there's our answer. Okay, so that's, now there will be some extras to it, and we're going to do another problem like that in just a bit. Okay, but for right now, go ahead and write this down. I'll answer questions after we do one more problem, and we write the steps out, and then I'll let you ask questions either on number 12 or this upcoming problem. Let me tell you, that is one of the easier problems, so don't feel too comfortable. That's one of the easier problems on tonight's homework, okay? I am just showing you kind of the basics, though, on how easy some of these are, or can be. If anyone got this confused, because some of us are still struggling with integers, which is going to be very hard if we struggle with integers. Negative 5. If some of you guys still didn't see where I got negative 11, again, ladies and gentlemen, write your problem out, please. Okay, some of us still don't want to do that extra work, but we need to. And if you still need to build a t-chart, right, they're both negative value. 5 and 6, you add them up, that's how we get negative 11. All right. Okay, here we go. Next problem. This is the one we're going to do the steps on. Before we do steps, any volunteers?
4? Oh.
I'm going to do that. Thank you, ma'am. All right, so here we go. Page 163, problem number 11. So what I have is I have 5.32. When you're writing, don't worry about the headings or anything else. Just start writing the problem right now. Jasmine. Just start writing the problem like immediately right now. Okay, you can use the black marker there. Thank you. I could always fill in the other little stuff later. Times 10 to the 8th. Okay, that is multiplied with 3.54 times 10 to the 3rd power. Okay, here we go. Now, here's what step 1 is. And I guess we don't even have to say this is step 1. We can call this step star. Make sure that they're all in scientific notation. The reason is because the main reason is because that will set this second number into base 10, where when we multiply, then we can just know the bases are the same and we can add the exponents. Okay? But always make sure, because you're going to come across some that are not in scientific notation. Maybe one is, one isn't. Okay? Now, the nice part is they are both in scientific notation, so we're set for right now. Step 2. I'm going to go ahead and I'm going to multiply the two we can call constants, all right, or I guess all of it's constants, but the two numbers up in front. So in this case, remember calculators are allowed, so 5.32 times 3.54, all right? 5 and 32 hundredths times 3 and 54 hundredths equals, and here's what we end up with, 18 and 8,328 10,000ths, so 18.8328. Now comes step 3. We're now going to multiply our base 10 to get an answer. So when I multiply these, of course, this goes back to last week's lesson, right? The bases are the same, so times 10, and we add our exponents. 8 plus 3 gives us 11. Now, how many of you realize there's an issue here? The directions say evaluate each expression, express the result in scientific notation. So with those directions, what's the issue? 18 is larger than 10, meaning that it is not in scientific notation. Okay? So here's what we got to do. We have to use yesterday's skill or something that's closely related and do step 4. And that is, I'll just write down, you need to now change it to scientific notation. And again, step 4, you might want to put a star by it because sometimes it'll just be nice and pretty and end up in scientific notation. Sometimes it won't. So here we go. Now, follow me on this. Here we go. Now, we should know by now, of course, how to switch it to scientific notation, at least this part, right? We're going to move the decimal over once. I'm going to go ahead and rewrite it. So we have 1.88328. That is not it. Now, listen. When we move the decimal, remember something is happening with the exponent. Because when you're moving a decimal, that is showing a multiplication or division of 10. Right? That's the whole power of 10 thing. So, here's what you want to think of. Did this number, did we just make it smaller or larger when we went from here to here? Smaller, right? So we have to compensate for that by making the exponent larger. You have to like balance it out like an equation. So we're making this smaller, so we're going to make this exponent larger. And there is our answer. So basically here what we did is we divided by 10 here, but we multiplied by 10 here to balance it out. So you just change the way it looks. It still has the same value. Okay, now is the time to ask questions. If it's on step 4, if it's on whatever it is. Okay. Right here? So you're saying, how did I go from 11 to 12? Okay, so this is all part of step 4. So remember, this is not in scientific notation. Remember, scientific notation, basically that first digit has to be like a 1 through 9. That's basically what you're looking for. This digit's an 8, yes, but the whole number in front, I guess you should say, is that's 18, not 1 through 9, right? So that wasn't in scientific notation. So we have to switch it to scientific notation by moving the decimal like we did the last couple days. So in this case, we moved it just over 1. Okay, you follow me? So when we moved it over 1, though, when I said, did we get larger or smaller by moving it over 1? Well, we basically went from 18 point something to 1 point something, right? So this just got smaller. Now, all we're doing is we're converting this. And convert, guys, remember, you're not changing value, you're just changing the way it looks. So changing the way it looks, we've got to keep the same value. We can't lose that same value. So because we went here, we moved it over 1, meaning we actually divided by 10 is what we really did. We divided by 10 here. We added an extra 10 on here, which, because this is base 10, that got larger by 1. Because exponents, it's 10, and so remember, this is 10 to the 12th power is 10 times 10 times 10 times 10, 12 times, right? When it used to be 10 times 10, just 11 times. So when we move it over once here, it got smaller. We divided by 10, but I basically multiplied this by 10 to balance it out. So bottom line is if you're making this smaller, this is going to get larger. If you guys have to make this larger, then remember, this is going to get smaller. Okay? If I have to move the decimal like 2 times, then that is going to change by 2. Right? It only changed by 1 because I only moved it once. So the rules still remain the same from the last couple days on when we did just your basic scientific notation. Cool.
So if you're moving the decimal this way, it would be originally be like a negative exponent. So why would it be like positive 12? Because you move it negative from the tip.
Well, we're doing it like, watch this. 18.8 328. Watch. You have to watch carefully. Watch what happens to the decimal when I divide by 10. All it did was move over once, right? So that's what we did. We divided by 10. So when I divided here by 10, what I did, remember when we increase, right? Think about it this way. 10 to the second power comparing it to 10 to the third. Well, that is 10 times 10, and this is 10 times 10 times 10, right? So when you increase the exponent by 1, I'm just multiplying by an extra 10. So we divided by 10 here, and we multiplied by 10 here. So we still balanced it out value-wise. Does that answer your question? Okay. Any other questions before I let you guys try one? Okay, I'm okay with the questions. I told you this lesson is going to be kind of lengthy. There might be a lot of questions here. Okay, I'm going to check in with you guys in about 1 minute. Here's the problem I want you guys to try. Problem 24 on your homework. Try 24. All right, 1 minute. Go. No. Okay. I wouldn't put a $100 item under there. I had it locked away, so you're good. All right, anyone still in need of more time? Okay. Give you guys a little more time. Check in with you in a bit. Those of you that finished a little early, just keep going on similar problems. Don't try anything new, but similar problems. Keep going on your homework. All right, how many of you still need more time? Okay, give you guys about 10 more seconds there. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay, here we go. All right, so I'll go through our steps. All right, so step 1, are they in scientific notation? Yes. Step 2 is I'm going to go ahead and multiply our two numbers up front, okay, without the exponent. So I have 8.08 times 3 and 3/400, so 3.34, and I get 26.9872. Now, I'm going to go ahead, right? Step 3 is do my base 10. So 10 to the 6th times 10 to the 3rd is times 10. Base stays the same, right? 6 plus 3 is 9. Issue is it's not in scientific notation now, so we have to do step 4. So step 4 is I take my decimal point. I've got to move it over once to the left. So I end up with 2.69872. I just divided by 10. I just made it smaller by dividing by 10. So that means I need to multiply this by 10, which means I move it once here. I increase my exponent once there. Okay, questions? Okay. All right, let's go on to a second type of problem. All right, we've got like 3 or 4 types of problems on tonight's homework, so here we go. Oh, I said remind problems on 14, and actually I already did. Okay, take a look at number 14. What do you need to do first? Yeah, right. There's a one of the products are the factors. Okay, one of the numbers is not in scientific notation, so you need to make it in scientific notation. All right, here we go. Let's take a look, and we're going to do this one together right off the bat here. Let's take a look at problem 16. Okay, problem 16, we have 1.86 times 10 to the 8th power divided by, right? It's a big division sign, basically. It looks like a fraction, right? But we're going to figure it's division. 3.1 times 10 to the negative 4th. Now, listen, I'm actually not going to write new steps on this because there's really not new steps, okay? The steps are very similar, all right? And so here we go. I'm going to follow the same steps. First of all, they need to both be in scientific notation. Yes, they are. Step 2 is I'm going to compute the 2 up front. Well, the only difference here is this, remember, is no longer multiplication. It's division. So whenever I do this, I'm going to go ahead and put in 1.86 divided by 3.1. And I get 0.6. Now, step 3. I go ahead and I'm going to solve my base 10s. So 10 to the 8th and 10 to the negative 4th. We just did a problem like this in our warm-ups, right? 10 to the 8th divided by 10 to the negative 4th. Sorry if I said 4. Okay? And so that is times 10. Now remember, we're going to subtract. So 8 minus negative 4. 8 minus negative 4. It's a double negative, so we end up with 10 to the 12th. Step 4, make sure your answer is in scientific notation. It's not.
Excuse me for the interruption, but this message is for all Rayburn teachers. Due to the air quality, our water polo matches versus Granite Ridge today have been canceled, so please keep students in class. Boys water polo and girls water polo matches versus Granite today have been canceled. Please keep students in class. Thank you.
All right, well, at least you won't be missing the quiz, I guess. Look on the positive side. All right, here we go. So, scientific notation. I'm glad we have one like this. We haven't done one like this. Here we go. I need to make sure that this digit to the left is between 1 and 9, or the number, meaning I need to bring it over here. So, I end up with 6.0 rather than 0.6 times 10. Now, be careful. I just multiplied by 10. I just made it larger. So I need to divide this by 10 or make this one smaller. I moved it over once to make it larger. I'm dropping this once to make it smaller. And there is our answer for number 16. Okay, questions? Just be careful with the difference between multiplication and division, but the steps in general are just pretty much the same. All right, no questions? Here we go. Try out problem 18. Problem 18, go. Guys, those of you that don't have your logs signed still, please get them signed tonight. Don't forget. All right, how many of you need more time on that? Okay. Okay, anyone still need more time on that problem? Okay, about 15 seconds. Welcome back, guys. You guys win or lose?
They're all snags that on the test.
All right, here we go. 30 seconds. Turn to your neighbor and share problem number 18. For those people that just came in, guys, try to share with them. Try to catch them up. Go. All right, here we go. Now we come across a problem that's also a little different. We have to actually convert the top, the numerator part of our fraction to scientific notation. A little line here to break this up. All right, so here we go. I'm going to quickly do this since hopefully all of you guys are experts at it by now. We spent the last couple days on it. So 1, 2, 3, 4. So we have 9.95 times 10 to the 1, 2, 3, 4. 10 to the 4th, right? It's positive 4 because the original number is larger. So now they're both in scientific notation. Now I can go ahead and finish off the rest of this. So we have 9.95 divided by 5 equals 1.99. All right, that's already in scientific notation. All right, times, and now I take a look, 10, so 4 minus 2 is 2. 1 and 99 hundredths times 10 to the second. Okay, questions? All right, okay, here we go. Next kind of problem, let's take a look on page 163 at number 22. All right, now it's going to get really fun. Okay, you hear me say it's fun, I'm probably lying, so I'm just joking. Of course I wouldn't lie to you guys. All right, here we go. Number 22 is 9.518 times 10 to the 7th power minus 22,000. Okay. Now, here's the issue. We are now subtracting. Okay? We are now subtracting. And what that means is there's actually a couple of different ways you can do this. I'm going to show you one way that will pretty much work on any of the problems. Okay, do let me remind you guys, if realistically the math department does not allow you guys to use your phones for calculators. Okay, we haven't had an opportunity to talk about this, but that reminds me, you're not supposed to use your phones for calculators. Now, the reason why I'm letting people is because when I was about to teach this, I realized that this was a calculator type of lesson. Okay, so that's why I'm letting you. Please don't ruin it for everyone. I have some people that are a little off task when it comes to using their phones properly. Okay, please don't ruin it for everyone. I will. All right, here we go. Okay, here's what we're going to do. We're going to convert this to where we have the same base and exponent as this one. Now, you can do it a couple different ways. I'm going to take us the long way first because this will be probably a little easier for some students. All right? So here's what we're going to say. All right, we're going to say step 1, make sure, put it in scientific notation. Put it in scientific notation. Okay, anything that's not in scientific notation. In this case, this one isn't. So I'm going to go ahead and I'm going to convert it by going 1, 2, 3, 4 to the left. So what I have is I'm going to rewrite this 9.518 times 10 to the 7th minus 2.2 times 10, and I moved it 1, 2, 3, 4 times, so times 10 to the 4th. Step 2. I'm going to go ahead and I'm now going to move the decimal with the goal, I'll put a little arrow, with the goal of having the same exponent. So I could move the decimal to create the same exponent on either one of these. It really doesn't matter. Okay? Since we just converted this, I'm gonna, and this is on the right side, I'll just deal with this. I need to make sure that 4 turns into a 7. Now, from what we've been talking about here, how many times are we going to have to move the decimal? I have to turn that from a 4 to a 7. How many times do I have to move the decimal?
3.
3 times. Why? Because 7 minus 4 is 3. All right, so I'm going to move it 3 times. Okay, so now the question is which way do we move it? Yeah, that needs to get larger, so that needs to get smaller. So we're going to move it. So it's kind of the same idea. That's why we started with the easier ones, because now hopefully you see how this works. We're going to move this decimal left 3 times. That's getting larger. That needs to get smaller. So here we go. 9.518 times 10 to the 7th minus, and now I'm going to move this 3 times. 1, and actually you can go over to the side if you want and do it to give yourself more room. 1, 2, 3. So we have 0.0022 times 10 to the 7th. Now, we have them the same. Now here's what we're going to do. We're going to take those and we're going to actually subtract these. These we cannot subtract. Remember, when we multiply them, then we add it, or when we divide them, we subtract the exponents, right? But we're not multiplying or dividing. We're subtracting. These are going to remain the same. I am just going to do step 3, and that is I'm going to put add or subtract because the steps are the same if it was an addition problem. In this case, I'm going to subtract those 2 there. So we end up with 9.518 minus 0.0022, and I get 9.5158. And now, step 4. Oops, I'll just write this. I'll just write the word same. This stays the same, times 10 to the 7th. We converted them to be the same, where we can now just move it down to our answer. So addition and subtraction is a little different than multiplication and division. You have to have the same exponent, the same base 10, and then you just worry after that about what's up front. So I'll leave the steps up here for you guys, or hopefully you have them all down on your paper. Make sure you follow them, use them. Okay, this is something really new. So remember, first part is always still make sure they're in scientific notation. Now, when you get good, you can do step 1 and 2 right at the same time. You don't have to make sure that's in scientific notation. Okay, you can actually just convert it right into having the same exponent right off the bat. Okay, so if you wanted to do that, you could. But what I would recommend, don't get too fancy. Do step 1 and then step 2 separately right now. Step 3, you'll add or subtract those 2 numbers up front, and then keep your base 10 the same here. All right, questions? All right, problem 20. Problem 20. Give that a try. 1 minute. Go. Okay, who's still working? All right. You guys, questions on that one? Anyone still working on that? Okay. About 30 more seconds, okay? About 30 more seconds. Follow your notes, follow your steps. I know a lot of us, this is a challenge, okay? But use your notes to your advantage. All right? Some of us have not been used to using notes in math class in the past, all right? Now is the time to try to start using them. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay, here we go. All right, using the notes. Here we go. Scientific notation. That one is good to go. That one is not. I need to move my decimal point over. So 1, 2, 3, 4, 5, 6. It's going to go right behind that 6 right there. I moved it over. What did I say? 6. 1, 2, 3, 4, 5, 6. So 6. So I end up with 6.263 times 10, and then this was a larger number, right? So it's a positive 6 plus 5.4 times 10 to the 8th. Step 2, move the decimal so we have the same exponent. I need to either move this one to a 6 or this one to an 8. It really doesn't matter. I'll get the same answer either way. So, I don't know, because, I don't know, it doesn't really matter. Let's just go, since we're already moving this one, let's just use that one, I guess. All right, so we need to put that to 10 to the 8th. That needs to get bigger. That means that needs to get larger. That needs to get, that needs to get bigger. That needs to get smaller. That needs to get smaller by 2 or by 100, right? 2 powers from 8 or from 6 to 8. So since that is the case, I'm going to move this. This is what I'm talking about. I'm going from 6 to 8. It's getting larger by 2. I then need to move my decimal over to make this smaller 2 times. 1, 2. So we end up with 0.06263. Now I'm ready to go. Here we go. So step 3 is I'm going to go ahead and add or subtract the 2 numbers. Well, in this case, there's our addition problem I'm going to add. So my 5.4 plus 0.06263 equals, and I end up with 5.46263. And the nice part is it's times 10, and this is the easy part, right? I just move 10 to the 8th down. Guys, steps can be so helpful, especially on big problems like this that you're not used to. Use your steps. Follow your steps. It's not a weakness. It will become a strength. All right, to use your notes. Any questions? All right, one more type of problem here. Let's go ahead and look at problem number 10 on page 163. Okay, it's a word problem. Okay, so here we go. All right, so the speed of light is about 1.9 times 10 to the 5th miles per second. Let's close read this, by the way. All right, everyone's with me? All right, when I stop, you say the word. The speed of light is about 1.9 times 10 to the 5th miles per second. It takes about 500 seconds for light to travel from sun to earth. What is the approximate distance between earth and the sun? Write in scientific notation. All right, so let's solve a simpler problem, right? Let's say the speed of light goes 2 miles per hour. And then let's say it takes about 10 hours for the light to travel from one place to the other. What would you do to find out the total distance? Two miles per hour means for 1 hour. I already forgot what I said. What did I say? How many hours does it travel? 10. Okay. How far would it go? It went 2 miles per hour for 10 hours. What would be the total distance? How would I have solved that? No, 2 plus, it's not addition. 2 plus 10 is not 20. All right, 2 times 10 is 20. Okay, guys, listen. On your word problems, right? I mean, they've got everything mixed in here. They have addition, subtraction, multiplication, and division. You don't know what it is. That's why solving a simpler problem will help. Okay? The only reason why I did that is just to get this right here. That was my goal. Is to find out what do I need to do with this. So here's what we have. 1.9 times 10 to the 5th. I'm going to go ahead and do it down here. 1.9 times 10 to the 5th. Okay. Multiplied with 500. So here we go. I'm now, of course, doing my multiplication part. I need to make sure this is in scientific notation. So 1.9 times 10 to the 5th. This goes over 1, 2. So it's 5.0 times 10. We just made it smaller, so this is a positive exponent times 10 to the 2nd power. With multiplication, right? What do we do next? We multiply our 2 numbers up front. So 5.0 times 1.9 equals 9.5 times, and then, yeah, this is base is 10. Now, since we're multiplying these two, we're actually multiplying them, we can add the exponent. So 5 plus 2 is 7. Now, it does say what's the approximate distance. So are we talking miles or seconds? It's in miles. A distance is the length of something, measurement of length. Okay? Okay. Say that one more time. Stan? No, not that one. It says right in scientific notation. You're looking at the correct problem? Number 10. We're on number 10. Okay. Other questions, guys? Okay. I want you to try out problem 28. 28. Give you guys a couple of minutes. Go. Guys, this has been a very long lesson. It's okay. It's time consuming, but make sure that if you're one of the people that finish early, that you're doing the rest of your homework, or you don't have much homework at home. Not to say anything, but number 28 should look a little familiar to you, a little bit anyway. We'll talk about it in a little while. All right, guys. How many of you still need more time? Okay. Again, those of you that are finished, continue working on. This is our last type of problem on tonight's homework, so you can complete the problem or the rest of the problems in your homework at this point. All right, guys, 30 seconds. For those of you that are not quite done yet, go ahead and just share, of course, what you have so far, all right, with your neighbor. Go.
I got 5.8266 3 times 10 to the 6th power.
All right. Here we go. So looking at that, right? Multiplication, division, addition, subtraction. Who thought that that looked a little familiar? Why? Who can tell me why? Okay, we really, with word problems, especially with these harder word problems, we really need to start, trying to relate them to other problems that we've solved. Ladies and gentlemen, this is extremely close to our POD today. It's very much like our POD. Okay, number 28. Let's close read it. It says, the United States has a total area, including water, of about 9,826,630 square kilometers. Rhode Island is the... Okay, we're at this point not on task. One person. All right, thanks, Jaden. Let's go ahead and start over again. A little surprise and taken back by this class not following along. Let's try it again. The United States has a total area, including water, of about 9,826,630 square kilometers. Rhode Island is the smallest state, with an area, including water, of about 4 times 10 to the third square kilometers. About how many greater is the area of the United States than the area of Rhode Island? Ladies and gentlemen, that question right there, how many times greater is this than that? That was the RPOD today. That was a division problem. So, what do? We take, this is how many times greater is the area of the United States. So the area of the United States is greater. So we have, what was it? 9,826,630. And again, if you didn't, you could do it the way I just said. You could think about our POD. You could think of solving a simpler problem. See, a lot of people are racing, which is a little scary. You guys, solving a simpler problem, you don't want to do. That's a lot of work to do, to waste your time on doing unnecessary work. It takes an extra few seconds to solve a simpler problem to find out which operation to use. Throw a couple of fake numbers in there and see if they come out. Okay, not fake numbers like, oh, I'm going from 9,826. No, throw in the number 10. Okay, number 5, number 2, whatever. All right, here we go. So I have that number there, and I'm going to divide it by the 4 times 10 to the third. So I'm going to make that look like, of course, scientific notation. So 1, 2, 3, 4, 5, 6. So I have 9.826630 times 10 to the 6th power, because that was a large number, so it's a positive exponent, over 4 times 10 to the third. Now, using the calculator, I'm going to go ahead and divide 9.826630 divided by 4 equals 2.45. Now, really quickly, I tell you what, I'll write that for now. So I have 2.4566575 times 10, and now I'm going to, this is division, so I'm subtracting 6 minus 3, so it's times 10 to the third power. Now, it does say about, so I think what they're really wanting you to know, of course, is you can go ahead and maybe round this to just 2.5. I'm not going to be too picky on this part, on where you round it, but when it says about, that's meaning kind of estimate. Now, this could be it, or, of course, I can, since it's so small, I can convert it to an actual number. So I move the decimal over 1, 2, 3 to get 2,500. Now, rereading, okay, just like our POD, about how many times greater? So about 2,500 times greater. 10 to the third power. 6 minus 3 gave us 3. All right, it is challenging. Now, the nice part is there's some problems still left, but we've done a lot of your math homework right now in the lesson. That's one of the reasons why it took so long, okay? So, computing with scientific notation.